So now directly we come to the problems. Some problems we have seen. The problem number 1. There is a block is kept on the inclined plane. The inclined plane, this angle is 30 degree. 30 degree angle. And the plane is lubricated by a thick film of oil. What is the thick film? 3 mm. 3 mm is sufficiently less. 3 mm thick film. So as it is the very less, we'll see here. We'll just see the problem. The oil is there in between. The oil relative density of this oil is 0.9 relative density. That means specific gravity of the oil. And viscosity is given here 8 poise. Because poise is the CGS unit of the viscosity, dynamic viscosity, not kinematic. Okay? So this given information here, 3 mm thick, this rectangular solid block slides here. It slides. So you have to estimate here the terminal velocity of the block. Contact area also given here. The contact area is given 0.3 meters. You have to finding out the terminal velocity. So how to solve in this kind of the problem, we'll see. So first we, over the body, if you draw the free body diagram of this block, then you could be able to understand what is acting. It having some own weight, and that is the 90 Newton. It is in a inclined plane, that is a 30 degree inclined plane. So this force, if you resolve this force in 2 directions, so one direction will go in this way along the inclined plane, and one is the normal to the inclined plane. If you resolve this force, and as this angle is the 30, so definitely this angle will be 30. Because this is the perpendicular to this plane, and horizontal plane, this is the perpendicular. This is 30. This side cos component will come, this side sine component. This force can be balanced because it is staying here, no upward or downward. So about this side, no movement is there of the slide. So this force is somehow balanced. We are not considering this force. It is balanced force. Next is the, what about this force? Inclined. It is balanced by some frictional force. Some frictional force due to cause of the viscosity. And both force balance, then only we'll get the terminal velocity. Concept of the terminal velocity is coming. Concept of the terminal velocity is coming along the direction of the velocity. Along the direction of the velocity, net force is 0. Net force is 0. So it is a uniform velocity. No change of the velocity. Net force is become 0. Whatever the velocity you are getting, this velocity is known as the terminal velocity. That is the concept of the terminal velocity. So here you are asked to finding out the terminal velocity of the block. That's why it is telling that there is some force along the velocity. So velocity is along the inclined plane. So along the inclined plane, all forces are balanced. it is telling that along the inclined plane, all forces are balanced. So that is what. So along the inclined plane, one force is this force due to cause of the sine component of the weight, and another is the cause for the due to the viscosity. Another is cause for the viscosity. If these two are balanced, then only you will get the terminal velocity of the cloud. The concept of terminal velocity then only coming here. After that, nothing is there. It is a very easy. Only this kind of the concept is required for the problem. So these forces are balanced. So in that direction, along this 90 sine 30. In this direction, force due to cause of the viscosity, frictional force. That is nothing but tau into A. So the remaining task is easy. So if you can be able to do, then you can get the whatever the velocity you are getting, that's nothing but terminal velocity. So now we have to go searching for the shear stress. What is the shear stress? So in this plane, if you're considering, this is stationary and this is the moving. So it is looks like it. So one is stationary, another is the moving. This moving with some velocity, v. That is nothing but a called terminal velocity you are telling. Because along the inclined plane, all forces are balanced here. As along the inclined plane, all forces are balanced. So this is the same v will come here. Now this gap is very less. This gap is very less. That's why the velocity profile, if you draw the profile, is nothing but a linear in here. Profile, if you draw here, there is a linear profile. Linear profile here. So du by dy, linearization of the v minus 0, h minus 0. So v by h. So tau will become easily mu into v by h. Mu value is given here 8 poles. If you convert these poles, if you remember this thing, the 1 Newton per meter square into second, Newton second per meter square is equal to 10 poles. Unit conversion we have seen it. It is given as. So in the SI unit, we can write it down 0.8 Newton second per meter square. Newton second per meter square. And h, the gap between this is given as a 3 mm thick plate. 3 mm, 3 into 10 to the power minus 3 meter. So 0.8 into v by 3 into 10 to the power minus 3. Yes. So force, shear force, tau into A. A is given, contact area in this problem, 0.3 meters. A is also given, so force is also, you are getting it here, 0.8 into V by 3 into 10 to the minus 3 into 0.3. This should be obviously equal with the 90 sine theta. Then only this V will be the terminal velocity. Then only this V will be the terminal velocity. So sine 30 is nothing but the half, so 90 half is the 45. 90 half will comes in the 45 here. So remaining is the simple thing, just for the calculation. If you do the calculation, you'll get this one. So this kind of the problem, just concept the force balance, linearization of the Newton's laws of viscosity, and the concept of the terminal velocity. So concept of the terminal velocity is much more important. That is the thing here. What is the concept? Along the velocity direction, all forces are balanced condition. So along the velocity direction, if the all forces are the balanced condition, then the velocity is known as the terminal velocity. So that's why we made the along inclined plane, all forces are balanced. So 90 sine 30 is equal with the shear force is acting in here. So now the V value will comes in this way. So 3 will be here 0.1. So 0.08 into 1000 into V. So 80 V into 45, V will come 45 by. So this is the answer will come 0.56 something will come. That is a meter per second. That is the terminal velocity. 45 by 80. If you calculate, you will get some values. So 0.5625. You can verify this answer. So concept is kind of the problem. The terminal velocity concept first is you require to finding out. After that, the force balance you will do, and you will get this answer. And linearization of the Newton's laws of viscosity. This one type of the problem. This is another type of the problem. It is also here the thin plate. One thin plate. It is the thin plate is placed. Here the thin plate is placed between at a distance in between these two plates. The total distance is the h. Here. This is the h. And h is also a small quantity. So h is as small. So linearization of Newton's laws of viscosity is applicable as h is small. And here the top side liquid, there is some liquid, top side liquid having viscosity mu1 and bottom side liquid having viscosity mu2. There is something different liquid, there is also different liquid having a different viscosity mu1 and mu2. In such a condition, you have to determine the position of the thin plate such that the resistance to the uniform motion will be minimum. What does it mean? We'll see. So first consider this is the here the thin plate is placed between here. Viscosity is different. Flat surface, the flat surface, it is a stationary part. This is also stationary. This thin plate can be movable here. It can be movable here. And let you take this velocity nearly v. So as the linearization of the Newton's laws of viscosity is applicable here. So if you put here the tau in this case. So what is the distance? We don't know here. So let you take it is a y. And remaining part is the h minus y. Total is the h. So this side is the y, this side is the h minus y. So for shear stress due to this liquid, let you take here the liquid A. Liquid A is the liquid B. Liquid 2, 1 and 2 is better, mu1, mu2. So liquid 1. So due to cause of the liquid 1, we got some shear stress here. And that is tau 1. What is the tau 1? Mu1, linearization is the viscosity, B divided by H minus. and tau 2, similar way, we can write it mu2 V. What is the force? If the contact area is the same for the both cases, so force will be equal to F1. Now the total shear force is the same side because this big velocity is the same direction, so shear force also upward side and bottom side is the same direction. So that is the F1 is F2. F is equal to F1 plus F2. So it comes in this way. VA is only the velocity into area is the only outside, mu1 h minus y plus mu2. Hence here they are asking about the determine the position of the thin plate such that the resistance to the uniform motion will be minimum. That means the resistance to the uniform motion will be minimum when if you is minimization of the force. If the shear force is minimized, then only it is come to the nearly uniform motion. So such a case, if you differentiate this force with respect to the y, so what should be the position? This thin plate position where should be? This y is the unknown quantity here. If you differentiate this thing with respect to the y and make it 0, so you'll get the minimization. Resistance, you can minimize the resistance because this the force is the resistance force. This resistance force you can minimize it here. So that's why you set this y in this way. If you differentiate this thing, you'll get y square minus 1. Another is the is equal to 0. So here, hence you are getting this here, the ratio that is h minus y by y. That is the position fixing what ratio you should keep it. It will come in this way, mu1 by mu2 to the power half. If you put this in this way, you will get the resistance that will be minimum. So in this ratio, if you put the thin plate, you will get the minimum resistance there. That is another kind of the problem. Here also you are applying the linearization of the Newton's laws of viscosity. So hence you are getting the force, total force, F1 due to the liquid, top side liquid, F2 due to the bottom side liquid, but the direction is the same. You get the net shear force. After getting the net shear force, you minimization of this thing and you will get some values. That will gives you the idea that shear force will be minimum at this condition. If you put the plate in such a way, you'll get the minimum shear force. That is one problem. Here, one type of the problem you are getting it. That is one type of important problem. It is a bearing lubrication, soft and slip. Soft and slip means there is a bearing. In the bearing, there is soft. So it is a soft, which is moved. So hence, in between the oil is there. There is some oil. So inner cylinder is the moving, and outer cylinder is the stationary. So this is the moving part, this is a stationary. And it is a moving at what RPM? 200 RPM. Inner part is moving with 200 RPM. This is known as a shaft. And this is the slip or bearing. You can draw this in this way also, lengthwise. Another view. Even this one. So this part is the sleep part. This is shaft. So what they are telling is the sleep length. Sleep length is given as this length. This length is also given. This length is 100 mm. Sleep length is given as the 100 mm. And here the diameter is given, diameter of the shaft is given as a, so diameter of the shaft is 0.58. And shaft rotation is the 200 RPM. So what is the omega n? Shaft angular velocity 2 pi ns by 60. That is omega. So linear velocity of the shaft. So at this point, what should be the linear velocity? At the circumference. If you take a point on the circumference of the shaft, what is the linear velocity? Linear velocity of the shaft at any circumference will gives you omega into r. R means d by 2, ds by 2. That's a linear velocity. And gap you see in between gap is 1 mm gap is there. Oil film gap here is 1 mm. It's very small. So as it is very small, Newton's laws of viscosity, linearization, you can have a gap like you can consider the velocity profile is a linear profile here. Because your thickness is given very small. So Vs, first we're finding out the Vs. 2 pi ns by 60 into ds. Pi ns ds by 60 will gives you the velocity of the shaft. You just put the values. So pi into ns is given as a 200 into ds 0.5 divided by 60. So this value is coming nearly 5.233. If you do the calculation, this value will comes 5.233 meter per second. Now, if you consider in this case, it is same type of this one. One cylinder is in stationary, outside is a stationary, and inside is moving with some velocity. It looks like it this way. Previous case was a linear profile, flat surface. Now it is a rotating surface. But the consideration is same. So here also velocity profile, if you're taking as the in this way, linear profile, because the gap is very small, 1 mm only thickness is given. So what is the shear stress because of this? Mu into V minus 0 by H minus 0, linear. So mu V into H. So mu is value is given here, 5 poise. 5 poise, if you are converting into the Newton, so you have seen 5 by 10, so 0.5, you can write it down here. Newton second per meter square. If you convert this poise into the, and velocity 5.233, and thickness is given here, 1 into 10 to the power minus 3. So this will comes around 2.617 kilonewton per meter square. This tau value. If you got the tau, next task is the shear force. So tau, shear force F is equal to tau into area, contact area. Shear stress you are getting it, and what should be the contact area? Contact area will gives you the pi dn. Sorry. This is a circumferential area. Circumference, what is the contact area here? If you think about it, the circumference into the length. Circumference is the pi ds, circumference into the length of the sleeve. That is only the contact area. Circumference into the length, cylinder circumference, surface area. So that will comes in the value, if you put the value here, 6.5 into 0.5 into 0.1. LS is equal to 100 mm, so 0.1 meter. So it will comes around 0.41 kilonewton. That is the force. The force value you are also getting 0.41 kilonewton. How the force is acting? The force is nothing but tangential acting here. That due to the shear stress, whatever the force you are getting, that is nothing but a tangential force. Shear force. Because if you see the force direction is the tangential. If it is rotating in this way, so force will be in this direction. Shear force is in this direction. Tangential direction. From here, if you're considering the force, let me change the ink. From here, if you see the force direction is this. From here, if you see the force direction is in this way. So because of this force, some moment is creating about the center. And what is the moment? The force into the radius. That will gives you the torque. So because of this force, the force value is 0.41. So just I erase this part. Because of the force, some torque will be acted here. Torque due to tangential force. And what is that value? The torque due to the tangential force is the shear force into ds. Shear force is already came 0.41 into 0.5 by 2. It will come around 0.1027 kilonewton. Now the power loss, how much power loss? Power loss due to the frictional effect. Tangential force is the reason of the friction, viscosity. Torque due to the friction force, so power loss due to the friction will be torque into omega. So 0.1027 into omega 2 pi ns by 6. So this will gives you around 2.15. So that is the concept. So first you apply Newton's laws of viscosity, getting the shear stress. then the tangential shear force, then the torque, then the power loss. That is the step-by-step procedure to get this kind of the question. This kind of the question, if it is asking, you are going by this step. If there is given very small thickness, if the thickness is not small enough, then you have to go by integration procedure. Then you have to going by integration, no other way. Du dy some point, some r value, r point you have to finding out, then go by integration, then you can solve this kind of problem. But here the simple, given the thickness is very less, so directly we can put the Newton's linearization of the Newton's laws of physics. That is another problem. It's a very easy problem. Just I show you here. The profile is not a linear profile. So tau is equal to mu into du dy. It is not a linear. U is given to you. The profile of the u, as the profile of the u is given, just do one differentiation here. So one differentiation, 5 into 5 pi sine, so cos 5 pi y. So at wall means y is equal to latitude 0. Normally at wall means we know that y is equal to 0. From wall we are trying to calculate. From the wall we are going to calculate. That's the y direction. Velocity profile is a sine profile. Velocity profile is a sine profile. Whatever, in this way. So you are asked to finding out the shear stress at the wall. Wall means shear stress means du dy at wall. So du dy at wall. So what would be if you take it du dy at wall? So cos 0 is equal to 1. So 25. So tau value will come mu into this value 25. Mu is already given 0.5 Newton second per meter square into 25. So 12.5 answer for you in this question. But if you are asked that at y is equal to 0.1, similarly like that. So what would be the du dy values? It is very interesting. Y given y is equal to 0.1. So I have some values. Y is equal to 0.1. At y is equal to 0.1, your value will comes 25 pi cos 5 pi. 0.5 means half. So pi by 2. Cos pi by 2, cos 3 pi by 2, all values are 0, so it will come to 0. So your stress value will also come 0. That is interesting in this question. Because it's a 0.1, if you got it, sorry, here 0.1 means 1 by 10, sorry. So pi by 2 it will come. Pi by 2, sorry. So that is also 0. So this value will comes 0. Du dy at y is equal to 0.1 will comes as 0. Because 0.5 pi will comes as a pi by 2. So this is the one type of the question. They were giving the velocity distribution and you are asked to finding out the shear stress at some corresponding points. This is one GATE question recently asked in some GATE examination. That is the consider the fluid flow to infinite horizontal plates. Gap is given as the to infinite horizontal plates. A top plate is sliding with 3 meters per second. And flow is solely due to the motion of the top plate. In between there is some fluid. In between some fluid is. Bottom plate is stationary. They are asking as the to infinite number of plates. Bottom plate is stationary. And top plate is some moving parallel. flow. Quid flow is an example of the quid flow. One plate is moving, one plate is there. In such kind of a situation, you are asked to finding out that the flow between the plates is solely due to the force per unit area. You are asked to finding out. The force is due to the shear force. Shear force per unit area is nothing but the shear stress. You are asked to finding out the shear stress in terms of the Newton per meter square. So gap is given here. Gap is given 50 mm. You can go for the linearization. 50 mm is enough to do the linearization because infinite. With respect to the infinite, there is given the infinite horizontal parallel plates. So in compared to the length and breadth of the plate, this gap is very small. So, and 50 mm, you can go for the linearization of the Newton's laws of viscosity. So you could be able to write it E minus 0, H minus 0. So mu is given as the 0.44 kg per meter second. That is the same. We have seen the last day, the kg per meter second. And the same thing is just like Newton second per meter second. If any doubt, you can do by own. A simple thing. And V is given as the 3 divided by the 50 minus. So you are getting this answer. Force per unit area. This answer will come nearly 26.4 meters. This is the types of the questions normally regarding the viscosity. So most of the things we are applying the Newton's laws of viscosity. One problem was only shear stress they are asking. So many boundary layer problem they are asking about the shear stress. So this kind of the mostly problem they're asking in the exam. So other than this, we can go in not going too much details problem, integral type of the problem in these cases, just some type of the gate problems only we have discussed. If any doubts, you can ask me better in the by typing in the comments also. If any kind of the doubt you have regarding this topic, any problem you cannot, you face some difficulty to solve, then you can also tell me. Next topic will come the surface tension, and I will just finish this part 1 or module 1, which is regarding the fluid properties. So next topic we'll see regarding the surface tension.